Picture a 1953 Corvette, but with futuristic lines, a roaring V12 engine, and details straight out of a sci-fi movie. That's the Corvette 12 Air, a masterpiece created by Dave Kindig and his team at Kindig Design. Today, in this SpeedArt, we're not just modeling this incredible machine. I'll also show you how to master professional 3D design for vehicles and architecture. Welcome to the Arc Lugo YouTube channel. This ain't your grandpa's Corvette. It all started when a client told Kindig, "Build me something one of a kind." And boy, did he deliver. Fiberglass? Nope. Pure aluminum. Every curve was hand-hammered into a monocoque that's basically rolling sculpture. Can you even imagine that level of craftsmanship? Now we will talk about the 3D modeling you are seeing. When modeling a 3D vehicle, everything starts with a crucial step: properly organizing your blueprints or reference plans. This stage is essential to ensure the final model has accurate proportions and a high level of detail. Ideally, blueprints should be drawn in parallel orthographic projection because, unlike photographs, they avoid perspective distortion and provide clean, consistent lines to work with. In the case of the Corvette 12 Air, I had to adjust some discrepancies between views. The side image appeared more stretched than the top view. While not perfect, at least there was enough reference material to work with. As a vehicle artist, I know how challenging it is to achieve accuracy in a 3D model without professional blueprints where all views align precisely. Once we've aligned all the reference views for our vehicle, we'll start modeling the wheel rim. For this, we'll use a high-resolution image taken as perpendicularly and closely as possible to minimize perspective distortion. We'll begin with the central polygon, which will act as the rim's axis. It's essential to maintain this axis, since it allows us to use the mirror modifier and preserve symmetry. In vehicle modeling, a misaligned center can cause visual issues during wheel animation, making the rotation look uneven if not perfectly calibrated on the x-axis. The center cap of this rim has a pattern that repeats 20 times around the axis. To achieve perfect symmetry, we divide 360 degrees by 20, resulting in 18 degrees per segment, the exact rotation angle needed for each copy. Next, we'll model the rim's barrel. For this, I recommend using multiple references. I use PureRef on a second monitor. Once the main structure is done, we'll move to the spokes. Here, we'll separate the mesh and apply the mirror modifier on the y-axis to automate symmetry. This rim has 5 spokes, so after modeling and detailing one, we'll divide 360 degrees by 5, rotating each duplicate 72 degrees on the x-axis. If you plan to UV unwrap the rim, I suggest marking seams and preparing UV islands before duplicating the spokes. This saves time and simplifies the unwrapping process. Finally, we'll tweak the proportions, and our rim is ready. Modeling rims is an art since many details aren't immediately obvious, but with practice, you'll achieve professional results. In this case, our braking system is fully chromed, matching the rim's shiny material. We'll use the same workflow. First modeling the brake discs, then adding details like ventilation holes. If we need to repeat a pattern, we'll count the number of elements around the rim and divide 360 degrees by that number to determine the rotation angle for each duplicate. For the brakes, we'll use manufacturer blueprints, aiming for a balance between realism and optimization. It's easy to get carried away and add too many polygons when you see how realistic it looks, but this can cause issues later. A car with over 1 million polygons might look stunning, but won't perform well in game engines like Assetto Corsa, forcing us to optimize it afterward. with 5 years of industry experience. My advice is to maintain high quality from the start, but avoid excessive polygon counts, especially in less visible areas. Finally, we'll model the 12 Air logo using the original design's typography and save it as a separate asset for reuse in other parts of the car. This saves time and ensures visual consistency across the entire model. If this SpeedArt feels too fast, remember you can watch it at normal speed in the playlist on my channel, Arc Lugo. Now that we finalize the front brake disc, we'll adapt it to the correct size and position for the rear rim. You'll see how the wheels are starting to look absolutely stunning. If you're enjoying this, drop a like. It's free for you, but it's a huge help for me. It fuels my motivation to keep creating content like this. Also, if you'd like me to model another type of vehicle, a classic car, a supercar, or even a futuristic concept, let me know in the comments. I'd also love to hear where you're watching from, and if these tutorials inspire you to learn 3D vehicle modeling. Your feedback is what helps me grow. We're now tackling the tire modeling with an approach that balances efficiency and quality. I chose not to use a subdivision surface modifier because at this stage, I want to maintain precise control over our polygon budget. Every resource we save here allows us to be more generous with the vehicle's most visible areas, where details truly matter. This particular model is designed for those who demand authentic 3D realism. In the video description, you'll find links to purchase it, as well as to explore on Epic Games' FAB platform, where you can examine every detail in an interactive environment. I've also included links to my stores on CG Trader, Render Hub, ArtStation, and 3D Export, where you can see more of my work. The real excitement comes when we model the chassis and suspension. This Corvette 12 Air was meticulously customized by Kindig Design, and every component tells a story. The suspension isn't just a set of standard parts. It's an engineering masterpiece where every control arm, every joint was carefully designed for maximum performance. Kindig implemented innovative solutions like a unique mounting system that reduces weight while increasing stiffness, using special alloys you'd normally see in aerospace applications. As a 3D modeler, my challenge is to capture not just the shapes, but that mechanical craftsmanship that makes this vehicle unique. Every polygon must convey the designer's original intent, from precise angles of the control arms to the aerodynamic flow of chassis components. It's this level of attention to detail that separates a good 3D model from a true digital representation of automotive artistry. At this stage, we've already completed modeling both the front and rear suspension arms, and now we'll focus on the custom aluminum transmission. If you've ever seen this car at a show, you may have noticed they place mirrors on the floor, and there's a powerful reason for that. Every inch of this vehicle is a work of art packed with meticulous details. As an experienced 3D vehicle artist, I can proudly say this Corvette 12 Air is without doubt the most detailed model I've ever created. This quality level is reflected in its value, which is higher than my other available models. But believe me, when you see the final result, you'll understand why. Its fidelity to the real car is simply stunning, almost like having the physical vehicle in digital format. As we work on the exhaust system, we'll capture every detail. from the headers coming out of the engine, following its path along the undercarriage, to the iconic pipes emerging at the rear. Even the brackets and clamps are recreated with millimeter precision. Before continuing, I'd like to ask you a small favor that helps me tremendously. If you're enjoying this project, please like the video and subscribe to the channel. Your support is what motivates me to create more content like this. In fact, I'm considering modeling some iconic Trans Am vehicles, or perhaps some legendary classic motorcycles. Let me know in the comments which one you'd like to see. Maybe a 1977 Pontiac Firebird Trans Am, or perhaps a Harley-Davidson Fat Boy. You decide what comes next on the channel. Returning to our 12 Air, every component we're creating tells a story of automotive craftsmanship. The suspension with its machined aluminum arms, the transmission with its visible gears, the exhaust system that looks like a metallic sculpture. Everything in this car was designed to be admired from every angle, and as a 3D modeler, my mission is to honor that level of detail in every polygon. We're now carefully placing the 12 Air logo on each brake caliper, a small detail that adds that touch of authenticity, distinguishing the professional model. Next, we'll organize our meshes by material in the chassis. Chrome for shiny parts, metal for structural components, plastic for protections, and rubber for insulators. This is the perfect time for proper organization. We'll rename each mesh in Blender's outliner and group them in specific folders. It might seem tedious, but trust me, this discipline is what separates amateurs from professionals. Imagine this 3D model being purchased by game developers or modders. A well-structured file will let them edit each component without wasting hours figuring out what's what. In fact, many of my repeat customers specifically mention my file organization as one reason they keep buying my models. Now comes the most exciting part, the bodywork. Here we will use a subdivision surface modifier, paying close attention to our polygon flow. Every curve, every edge must be perfect, as this will be the first thing viewers notice. To ensure maximum accuracy, I'm constantly consulting my PureRef reference board, open on my second monitor, where I've collected dozens of images and even YouTube screenshots that help me capture subtle details a single reference photo might miss. Pro tip: when modeling high-end vehicles, spend as much time studying references as you do modeling. That obsession with detail is what will make your work exceptional. One of the biggest challenges we face as 3D vehicle artists is obtaining good blueprints, especially when working with unique cars like the 12 Air that aren't commercial production models. In this particular case, I had to work with reference images that, while useful, required extensive processing in Photoshop to correct perspectives and properly align horizontal and vertical lines. This preparation process is crucial, as a poorly aligned blueprint can cause proportion issues throughout the entire modeling process. My personal approach to modeling differs from a conventional technique of starting with a basic block. I prefer working polygon by polygon with a subdivision modifier activated from the beginning, which allows me to detect and correct geometry flow imperfections early on. When I encounter angles that are too sharp, I apply a control bevel to smooth the curves, but always in moderation. I leave the door, hood, and trunk cuts for later stages, once the main body shape is completely defined. An important technical aspect worth highlighting is the use of bevels. For visible body edges, I typically use 3 segments when working with subdivision. This is because the subdivision modifier applies Catmull-Clark smoothing, which parametrically divides each edge. Using more than 3 segments creates unnecessarily closed loops, resulting in an excessively heavy model that could cause problems in game engines. This is a lesson I learned through experience. It's better to optimize topology from the start than have another artist clean up the model later. The modeling process is complemented by careful reference review. In my case, I keep PureRef open on a second monitor with a collection of over 50 images of the 12 Air from different angles, including screenshots from videos that show details not visible in static photos. This meticulous attention to detail is what enables the creation of a truly professional model. Ultimately, the most important thing to remember is that a good model isn't measured by its polygon count, but by the intelligence of its topology and its fidelity to the real vehicle. Every technical decision should be made considering how it will affect a model's final performance, especially if it's destined for game environments where optimization is key. If you're interested in learning more about these techniques or have a different approach to vehicle modeling, I'd love to hear your thoughts in the comments. You can also subscribe to the channel if you want to see how I tackle interior modeling, where we'll apply special techniques to recreate details like stitched leather and other complex elements. We're now modeling the undercarriage of the vehicle. Early in my career, I used to leave open faces with inverted normals, those red highlighted surfaces in Blender, unattended. Back then, I didn't realize that game engines only render materials on front-facing, positive, normals, meaning those red areas would appear as transparent gaps or visual glitches in the final product. That's why I now always keep the face orientation overlay enabled throughout my workflow, especially in Blender 4.4, where they remove the distracting blue coloring for positive faces. Here's a pro tip. Never leave inverted normals red faces in your models. If the bodywork has a grille that should reveal part of the engine bay, you don't need to model the entire engine, but at least place a dark color placeholder geometry to prevent empty voids in the game environment. This same principle applies to AC ventilation grills in the interior, exhaust system outlets, air intakes on the bodywork. Every visible cavity must be properly sealed, because in a game engine, those inverted normals will break immersion and scream amateur work. As professional 3D artists, we must preemptively solve these issues during the modeling phase. We continue modeling our Corvette 12 Air, now with the main body shape established. During this phase, we keep proportional editing enabled, activated with the O key in Blender, to make subtle adjustments that refine the vehicle's contours. Once satisfied with the overall silhouette, we proceed to cut out the window areas. We carefully separate these sections from the main mesh, assigning specific materials: chrome for the frames and glass for the windows. It's critical to ensure window edges don't have overly sharp angles, particularly since we're using the subdivision modifier. Excessively sharp edges will cause distortions in the final smoothing, so we strategically apply bevels on curves to guarantee clean surfaces. For door and hood panel gaps, I follow a specific technique first applying a 2-segment bevel, then extruding inward along the normal's direction. Next, I select the inner loop to create a triangular structure defining the panel's thickness. Finally, we apply a 3-segment bevel on the outer loops matching the car's main surface. When enabling the subdivision modifier, this creates perfectly defined edges. We can further refine these cuts by adding supporting loops near the edges, but this must be done judiciously, always considering our polygon budget. We apply the same process to the front grille, where we also model the signature chrome elements of the 12 Air. These kindred design components are essential for capturing the vehicle's unique character, blending aggressive lines with refined metallic finishes that stand out in the overall design. We now focus on modeling those distinctive oval-shaped chrome elements positioned beneath the headlights and taillights, a signature design feature of Corvettes from that era. This process requires meticulous attention to ensure no gaps remain between the bodywork and chrome pieces, maintaining seamless transitions. A critical aspect is verifying these metallic claw-like components perfectly follow the 12 Air's body curvature. To achieve clean transitions between chrome and painted surfaces, we create a sharply defined edge before reaching the painted area. This technique prevents visible seams or unnatural material transitions. We apply the same treatment to the rear chrome oval beneath the license plate, replicating the detail level we implemented in the front grille. But here comes a distinctive 12 Air feature. The diamond pattern from the grille isn't an isolated detail, but a design motif consistently repeated across multiple vehicle elements, even on the leather seat surfaces. To ensure maximum fidelity to the real design, I created this diamond pattern in Photoshop, developing not just the base texture, but also a precise opacity map, defining the pattern's transparent areas. This approach accurately recreates the characteristic negative spaces when applied to the 3D model, maintaining visual coherence across all surfaces featuring this motif. At this advanced modeling stage, we've completed the taillights by meticulously separating each mesh according to its corresponding materials. We now focus on cutting the headlight shapes, a process requiring special attention to maintain the characteristic oval curvature while preserving the body's natural flow. These double curvature surfaces represent one of the greatest challenges and rewards in professional vehicle modeling. The precision with which we resolve these complex surfaces truly distinguishes automotive modeling specialists from other 3D artists. It takes a trained eye and considerable patience to achieve that level of realism where every form transition appears perfectly natural. Our methodology follows a structured process. First, we create the chrome frame using the same cutting technique previously applied to the hood. Then we carefully separate the glass surface of the headlight. The 12 Air design features a particularly interesting detail, a textured grid-like pattern beneath the glass surface. To replicate this effect in 3D, we'll model this geometric structure just beneath the main glass surface, creating that illusion of internal depth seen in real lights. In the physical world, this effect is likely achieved through negative molds in the glass/resin casting process. As 3D artists, our challenge is recreating this appearance through careful modeling and material work, always seeking that perfect balance between design accuracy and workflow efficiency. Some aspects of what I'm explaining might not be perfectly visible in the current video footage. I understand this could be slightly confusing, but please remember this isn't a traditional step-by-step tutorial. It's a SpeedArt where I share modeling tips and techniques as I work. If you want to follow the process more thoroughly, you can find a complete tutorial series on my Lugo YouTube channel, where each stage is explained at normal speed and in greater detail. I'd like to take this opportunity to invite you to subscribe if you haven't already, and especially to ask which vehicles you'd like to see modeled in future projects. Your feedback about video format preferences is also valuable. Do you prefer this commented SpeedArt style or longer videos with just background music? These comments help me continuously improve and deliver better content for you. At this project stage, we've completed the door panel cuts and will now meticulously cross-reference our PureRef board open on the second monitor. This review is critical for identifying and correcting any elements that don't match the real vehicle, such as establishing precise thickness for chrome window frames, verifying exact glass dimensions, ensuring the paint material shows no modeling artifacts. A key checkpoint is examining how both meshes, body and frames, interact with active subdivision surface modifiers, guaranteeing the final result maintains a clean, professional quality expected from production-ready models. As you can see at this modeling stage, we've completed both the side mirrors and all the chrome elements that define the sides of our Corvette 12 Air. This process wasn't just about modeling these parts and placing them, but involved meticulous integration work with the main body. Each chrome component, from the side moldings to the smallest details, required careful adjustment to ensure they perfectly follow the body's complex curves, maintain exact proportions relative to the real vehicle, present thicknesses and finishes consistent with automotive manufacturing. Before proceeding, we conducted a thorough verification, comparing our model with all available references in PureRef. This step is critical to identify and correct any imperfections that might affect the final realism. We adjusted minimal deviations in chrome element alignment, corrected imperfections in geometry flow, verified all edges have proper treatment for subdivision surfaces. Now comes one of the most rewarding moments in the process, applying the base paint color. This phase dramatically transforms the model's perception, letting us see for the first time how our 12 Air begins to come to life. The color selection isn't random. We faithfully recreated the vehicle's original paint code, carefully adjusting material properties to capture the characteristic depth of automotive paint. That subtle but present reflectivity, the perfect balance between base color and clear coat. Though we're currently only working on exteriors, we can already appreciate how all the hours of detailed modeling are paying off. The vehicle begins to show that imposing presence that characterizes it, with its fluid lines and reflections that only good modeling and materials can provide. As you've seen in the project progress, we successfully completed modeling the rear license plate housing for our 12 Air, a seemingly small detail that requires special attention. In this area, we've not only created the physical space of the plate, but also faithfully integrated the vehicle's logo, reproducing every curve and finish exactly as it appears on the real model. To maintain visual consistency throughout the model, we've smartly reused the 12 Air text we modeled in early project stages. This practice not only optimizes our workflow, but ensures uniformity across all typographic elements of the vehicle. We're now entering one of the most technical modeling phases, the engine section. The process begins with meticulous separation of the hood from the main body mesh. This step requires special care because we must respect the original design lines. We need to assign proper thickness to the panel. We have to perfectly integrate chrome components like hinges and locking mechanisms. The 12 Air presents an interesting challenge with its aluminum monocoque construction. This characteristic means the entire structure is essentially one continuous piece, forcing us to be extremely precise with transitions between different vehicle areas, representation of structural joints, integration of mechanical components. Fortunately, Kindig Design's team have provided valuable reference images, particularly a top view of the engine compartment that has been invaluable for our work. This level of access to detailed information is a privilege we don't have with all projects. Completing the exhaust system, we precisely modeled the rear lower outlets, paying special attention to clear separation between chrome components and painted surfaces, internal geometry of the pipes, integration with the monocoque structure. Each of these elements contributes to the model's overall authenticity, and it's this attention to detail that distinguishes professional modeling from amateur work. We've begun modeling one of this vehicle's most iconic components, the 12-valve engine block that not only gives the 12 Air its name, but represents the mechanical heart of the entire project. This process requires exceptional detail, as we're recreating every element with absolute fidelity to the real engine. The work starts with the exhaust manifold, where we've paid special attention to perfect alignment with the main exhaust system, smooth transition between different pipe diameters, mounting points and brackets, recreating even specific fasteners. The valve cover receives particular treatment, where we meticulously separate each material. Engine block, matte red high-temperature paint, applying correct physical properties to simulate the characteristic textured finish. Exhaust manifold, chrome surface with proper reflectivity, including temperature and wear variations. Diamond pattern. We intelligently reuse the mesh created for front grille, adapting its scale and depth for this component. Brushed aluminum. We recreate the distinctive metallic finish with its specific brushing direction. The combination of these materials and finishes creates a visual spectacle that goes beyond simple 3D representation. Each surface interacts with light differently. The matte red softly absorbs light. The chrome intensely reflects. The brushed aluminum offers directional reflections. The diamond pattern creates complex light and shadow play. This level of detail isn't just aesthetic. It faithfully responds to the real engine's technical characteristics. We meticulously studied reference photos and technical diagrams to capture even the least visible details, like casting marks on the block, texture variations by zone, small temperature and pressure indicators. The result is a representation that not only looks authentic, but communicates the very essence of the 12 Air, the perfect union between automotive art and engineering. Every modeling and material decision contributes to telling the story of this unique engine, from its conception to its final implementation in the vehicle. We're in the final stages of modeling our Corvette's engine, and now we'll focus on the doors. By working with symmetry, everything we model on one side will automatically replicate to the other, optimizing our workflow. My methodology for this process begins with meticulous organization in Blender. I create a specific folder in a directory where I group all door-related meshes, naming them descriptively like door paint, door chrome, door glass, door mirror, etc. This hierarchical organization is crucial for maintaining order in complex projects. With the door meshes properly organized and temporarily hidden, I begin modeling the inner frame and the empty space left by the main door. This process requires special attention to functional details. I precisely recreate the waterproofing rubber seal, the exact space for hinges, the housing for the locking mechanism, and all structural elements, using as reference YouTube video screenshots that show the real vehicle from all angles. Once the frame is complete, I use a specific technical workflow. Select the frame faces with Ctrl+D, separate them as an independent mesh with the P key, then flip their normals. This operation allows me to essentially create an exact negative of the frame that will integrate perfectly with the main door we had hidden. The result is an assembly where both geometries fit with millimeter precision, replicating the perfect alignment found in the real vehicle. With this solid foundation established, we proceed to model the door's interior panel, where we'll add all its components, from window controls to decorative finishes, including practical elements like storage compartments. Each component is modeled with the same level of detail and attention to real references, ensuring the final result is not only visually accurate, but also technically coherent with professional automotive construction. This vehicle's door panel features an exquisite material combination, including premium leather, chrome accents, and a diamond mesh pattern I originally modeled for front grille, later adapted for the engine valves and as decorative elements on the valve covers. This design consistency isn't accidental. It represents a holistic design philosophy where every visual element is meticulously planned to create a unified aesthetic experience. In fact, this attention to detail and thematic coherence is what has earned the 12 Air numerous awards at prestigious automotive shows. When completing the door modeling, I strongly recommend dedicating time to develop precise UV maps for all meshes receiving PBR texture materials, especially surfaces requiring high fidelity like leather and the diamond pattern. This step is crucial to ensure the design's finest details display correctly in final renders or game engines. Moving to the vehicle interior, it's essential to keep Blender's face orientation display active, ensuring no red faces, indicating flip normals, remain. At this critical modeling stage, we conduct a thorough quality check of the door assembly, ensuring it meets all professional standards. The process includes modeling the chrome door handle, faithfully recreating Kindig Design's exclusive pattern, where every curve and surface has been meticulously crafted to capture the original concept's essence. As part of our commitment to realism, we've incorporated visible hinges and meticulously verified that the door lock mechanism perfectly matches references from the actual vehicle. After completing the primary modeling, we apply final materials and finish UV mapping all components. The next technical step involves applying the mirror modifier to each mesh, automatically generating symmetrical geometry for the vehicle's right side. To maintain professional file organization, we select all right side elements, separate them into independent meshes using the P key, implement our naming convention with L left and R right suffixes. Example, door paintel, door chromar, etc. This naming system isn't arbitrary. It allows any future model users, like developers or artists, to easily identify and modify each component. For door animation and manipulation, we create strategic pivot points. Insert Blender empties named DoorL and DoorR. Establish parent-child relationships between meshes and their respective empties. Carefully position these pivots at the exact hinge rotation points. This technical setup enables realistic movement when animating opening/closing, easy adjustment for different angles, game engine compatibility. With doors completed, we begin interior modeling with equal professional rigor. This process resembles creating an inverted shell, where we must meticulously cover headliner interior lining, A, B, and C pillars with proper thickness, floor pan, allowing space for mechanical components, all visible corners from any angle. We constantly monitor face orientation display, ensuring no red surfaces appear, indicating flip normals. This quality control is essential because it guarantees correct renders, prevents game engine issues, ensures proper material behavior. Every detail, no matter how small, contributes to the final model's authenticity and professional quality. The 12 Air features a particularly interesting design element. Portions of the custom rear suspension are visibly integrated into the cabin space, serving as intentional decorative components beyond their functional role. For these components, we're modeling springs with their specific geometry and material properties, protective covers in high-quality leather, reinforcements and perimeter details in polished chrome. Every design decision in this automobile has been carefully considered to achieve extraordinary visual impact. From materials to shapes, everything converges to create a cohesive, high-end aesthetic experience. If you find this content valuable, I invite you to support the channel with a like. A simple gesture that represents tremendous motivation to continue producing material of this quality. For those not yet subscribed, it would be an honor to have your support. I'll also be delighted to read your suggestions in the comments about what other vehicles you'd like to see modeled on the channel. Your active participation is key to growing and improving the space dedicated to high-end automotive modeling. At this project stage, we can appreciate the impressive detail achieved in Kindig's custom rear suspension system. Each component has been modeled with millimeter precision, from special screws with perfectly defined hexagonal heads to spherical joints enabling suspension movement. I'm particularly proud of the stabilizer bars, where I recreated not just their shape, but also visible manufacturing marks on the metal. This dedication to detail makes the 12 Air the most complete model in my portfolio, available across multiple digital platforms. But beyond showcasing this work, I want to share why 3D vehicle modeling is one of today's most valuable digital specialties. The value of being a vehicle 3D artist. Sustainable passive income. Well-executed models can sell repeatedly without additional work. In my 5-year experience, early models still generate monthly income. My portfolio functions as a digital car fleet working for me. Multiple revenue streams. Complete model sales, from low poly to hyperrealistic. Materials/texture packs for other artists. Tutorials and courses on vehicle modeling. Freelance work for game/film studios. Custom commissions for collectors. Design licensing for simulators and education. Competitive advantages. Entertainment industries constantly need vehicles. Driving simulators/VR demand accurate models. NFT/metaverse markets created new demand for premium 3D assets. Concrete monetization example. One of my first models, a classic muscle car from 4 years ago, has sold 37 times as complete model, sold 15 times as material pack, been licensed 3 times for educational projects, been used in 2 indie games via royalty agreements. Growth perspectives. The 3D vehicle market is expanding due to popularity of games like Forza Horizon, growth of automotive VR/AR experiences, digitalization of car dealerships/shows. Continuing the 12 Air. Next is the center console, where we'll apply organic design principles to create that characteristic flow. Every curve will be reference studied to ensure. Controls are ergonomically positioned. Materials feel authentic. Stitched leather, brushed aluminum. Ambient lighting perfectly highlights the forms. This dedication separates ordinary models from digital collectibles that can generate value for years. The Corvettes of this historic era were characterized by their iconic dashboard designs with elegant crescent-shaped arches, a stylistic element that Kindig design has masterfully reinterpreted in the 12 Air, adding their signature touch that distinguishes it from any other vehicle. This dashboard isn't merely a functional component, but a true design piece where every curve and intersection has been carefully calculated to create a unique visual and tactile experience. When modeling the central interior element, we follow a meticulous process. Primary form definition. Establish master lines following the vehicle's design language. Respect characteristic arches while integrating Kindig's innovations. Ensure surface continuity with the center console. Strategic cutouts and openings. Space for the gear shift with realistic mechanism. Precise housing for the analog dashboard clock, a reinterpreted vintage detail. Integrated cover for function controls with articulated movement. Structural quality control. Thorough verification to eliminate any gaps or discontinuities. Guarantee all surfaces are perfectly sealed. Topology optimization to support subdivisions without deformation. The material selection for the dashboard is a study in chromatic and tactile harmony. Premium leather, 4 high-contact surfaces. Polished chrome for light-catching details. Brushed aluminum For visible structural elements, diamond pattern inlay as a design through line. This coherent material approach isn't accidental. It represents Kindig's philosophy of creating interiors that are true mobile art galleries. Each material was selected not just for aesthetics, but for how it ages over time and interacts with other components. The 12 Air is effectively a material symphony where every texture converses with adjacent ones. Reflections complement rather than compete. Material transitions are deliberate tactile experiences. For 3D modelers, this project represents a masterclass in interpreting classic designs with modern sensitivity, handling complex materials in digital environments, integrating mechanical components into design spaces, technical enhancements, dashboard ergonomic considerations, vintage modern design fusion, material aging simulation, articulated component modeling, tactile experience design. We're moving forward with the dashboard modeling, paying special attention to that crucial transition between the door and dashboard where many models often fail by leaving gaps or discontinuities. To achieve maximum accuracy, I've been analyzing multiple YouTube videos with detailed reviews of the 12 Air, which by the way is becoming hugely viral. And that's a big advantage for us because there's plenty of reference material available. When the doors are closed, you can appreciate how the design flows seamlessly from the doors into the dashboard, creating that uninterrupted sensation that makes the interior look like it was sculpted from a single block. Here's a pro trick I always use. With Blender's proportional editing, we carefully adjust the width of the dashboard arches. But beware, our brain can play tricks on us. What looks like a perfect circle to the naked eye might be slightly deformed when measured against geometric references. That's why I always use a reference circle as guide, especially for curved elements like the characteristic crescent shape on the passenger side, where we've integrated the 12 Air logo we modeled earlier. On the driver's side, every gauge, every button, every texture was created exclusively for this vehicle. There are no placeholders or recycled elements from other models here. That's one of the things that makes the 12 Air so special. It's as if every millimeter of this interior was designed to maintain perfect visual harmony, where everything converses with each other. If you're enjoying this modeling process, tell me in the comments which interior part interests you most. The seats with that diamond pattern? Or maybe the center console that flows like a wave? Your feedback really helps me plan future content. And if you haven't yet, subscribe to the channel, because very soon will come the materials and rendering phase, where all this work will come to life with those reflections and textures that take a model from good to spectacular. Remember, the video description has all links to my stores where you can get this and other models, from affordable options for personal projects to gems like this 12 Air for professional productions. And if you have questions about any step of the process, ask me below. I'm always happy to help our community of 3D artists who follow us. Now that we've completed the dashboard foundation, it's time to bring the 12 Air seats and carpets to life. Where the iconic diamond pattern we've been using reappears in the floor mats, creating that visual coherence that makes this vehicle unique. For the leather seats, I've opted for a truly special solution, using the same color tone but with two design variants. The first is traditional smooth leather, while the second incorporates the heat-embossed diamond pattern, a technique that produces a shiny, luxurious visual effect. This detail makes all the difference. Many designers would have taken the easy route with embroidered diamonds, but Kindig went for the premium option, demanding perfection. The seat's monolithic shape, with that characteristic L contour, pays homage to classic race cars, but with modern refinement only seen in high-end vehicles. To ensure perfect proportions, I did something not all modelers consider. I used the Assetto Corsa driver as a verification reference. Why? Because I needed to be certain that the virtual driver's hands comfortably reach the wheel. The driver's helmet doesn't protrude from the vehicle geometry. The driving position feels natural and realistic. These validations are pure gold for modders who acquire this model. Imagine their frustration if they had to manually adjust these parameters. The 12 Air, like all sports cars, has compact, low dimensions where every millimeter counts. Moving to lighting details, we're recreating that distinctive LED tone between white and light blue that illuminates door controls and creates that futuristic yet elegant ambience. But the real challenge lies in the central analog clock, a seemingly simple element requiring special attention. We've modeled it within a glass recess, following the dashboard's fluid wave. Each hour marker uses small LEDs with that characteristic tone. The clock numbers use a meticulously selected font to match the original. We deliberately reduce polygon resolution on the numbers to keep the model optimized. Here's valuable advice. That decision to lower resolution on certain elements isn't accidental. In game modeling, every polygon counts, and knowing where you can economize without sacrificing quality separates good modelers from exceptional ones. Check out what we've got here. We just finished the pedals, those two metallic kidney-shaped pieces with a signature diamond pattern finish that defines the 12 Air. Since we're modeling the automatic version, there are only two pedals, but trust me, we put just as much care into them as if there were three. Now, we're moving on to a crucial part, the steering column and that special recess for the gauges in the left crescent of the dashboard. Here's a secret I learned the hard way. Always use the center of the steering wheel as your reference point, and make sure it lines up perfectly with the driver's seat. You know how many times I had to redo entire steering wheels because I ignored this simple rule? Way too many. That's why I'm telling you up front, so you don't make the same mistakes I did. The gauges are a true work of art, divided into 3 zones like precision jewelry. And speaking of precision, here's another golden rule. Stick to 3 segment bevels for hard edges. Yeah, I know, it's tempting to add more for that extra polish. But in game modeling, optimization is king. Developers who use this model will thank you later when they don't have to spend hours fixing over-detailed geometry. What do you think about these details? Ever had a misaligned steering wheel like I did? Let me know in the comments. Your experience helps all of us grow. And if you're finding this content helpful, don't forget to drop a like. Every bit of support keeps me motivated to share these trade secrets that usually take years to learn. Now, a little sneak peek. Next up, we'll be working on those chrome reflections that make the 12 Air shine like no other. Got any special tricks for metallic materials? Share them below. This channel is all about community. And if you don't want to miss the final material reveal, hit subscribe. The best is yet to come. By the way, for those asking, the full model will be available in my stores, links in the description, fully optimized for games, but without losing any of that luxury and detail that makes the 12 Air one of a kind. What other car would you like to see modeled at this level of detail? Let me know. Your suggestions shape future content. Don't forget, like if you're learning something new, comment your thoughts or questions. Subscribe so you don't miss the final reveal. Check the description for purchase links to this model. Now we're adding the final details that really bring our dashboard to life. The analog gauge needles and those tiny LED lights that illuminate each number and indicator. This gauge cluster has a sleek black background to make all the important information pop. Here's a pro tip I've learned over the years. When modeling the numbers and letters for gauges, we dramatically reduce the polygon resolution while maintaining visual quality. Those curve edges on small numbers don't need high poly counts. They just unnecessarily bloat our model. If this were a low poly vehicle, we could have just painted these details in Photoshop, but for the 12 Air, we're committed to maximum authenticity. Let me walk you through what each of these indicators means, because I remember when I first started modeling and had no clue. F and E for fuel, showing your gas tank level. Temp for engine temperature. RPM for engine revolutions. MPH for speed. Oil and volt for battery/oil systems. Water for coolant temperature. We're carefully checking the x-axis tilt of each number to ensure perfect alignment with the black gauge faces. It's these small details that separate good models from great ones. Quick question for you. When you look at a car's dashboard, what's the first gauge your eyes go to? The speedometer? RPMs? Let me know in the comments. Remember, the purchase links for this fully optimized 12 Air model are in the video description. And if you're just starting your 3D modeling journey, don't get discouraged. We all began not knowing what RPM stood for. Drop a like if you found this helpful, and subscribe to see how we'll bring these gauges to life with lighting in the next episode. Pro tip for beginners. Always ask questions when you're unsure. That's how we improve. What other dashboard details would you like me to explain in future videos? We're in the home stretch of the 12 Air modeling. Just the steering wheel left and that final quality check to ensure a flawless model. But before we finish, I want to share a professional secret I've successfully used for over 5 years that few artists talk about. When working with clients who commission 3D models, I use Sketchfab as my magic feedback tool. Why? Because it's completely free for basic use, supports high-quality PBR materials, allows daily progress sharing with a simple link. Imagine this. Your client can see every morning how their model comes to life, suggest real-time adjustments, and even approve alternate color versions. If you're paid hourly, Sketchfab becomes your best ally. It shows exactly the progress made each workday. The client excitement seeing their project become more realistic daily is priceless. And for us artists, this builds a reputation of professionalism and transparency. Yes, other platforms like FAB or Marmoset exist, but after years of testing alternatives, Sketchfab remains my favorite for its fast loading, intuitive interface, visualization tools, use a number pad to toggle wireframe, UVs, bump maps, etc. This tip has been key in my career. Few share it, but it makes a difference between a freelancer and a true 3D professional. What do you think? Have you used Sketchfab to showcase your models? What other tools would you recommend? Let me know in the comments. Your experience helps the community too. And if you found this tip valuable, don't forget to like the video. That way I know to share more professional secrets like this. By the way, the complete 12 Air model will be available in my stores, links in the description. Fully optimized and ready for your projects. What other vehicle would you like to see modeled at this professional detail level? Subscribe if you don't want to miss how we'll apply the final materials and those LED lights that will make this steering wheel shine.